present now the screen? Is it visible? Screen?
Yes, ma'am.
So all these points we have already discussed during Monday's lecture, the design steps for torsion, and we also solved one numerical example, this numerical example. We will solve the second problem today. So just all of you note down the problem statement. I am simply reading the problem statement now. A RC beam of rectangular cross section with a breadth of 350 mm and overall depth 800 mm is reinforced with four numbers 20 mm diameter on tension side at an effective cover of 50 mm. The section is subjected to ultimate moment of 215 kilonewton meter. Estimate the ultimate torsional moment that can be allowed on concrete. Use M30 and Fe415 materials. So all of you please note down this problem statement. Once you finish writing, please let me know. Is it over? Hello, students?
No, ma'am, it's right.
Okay, okay.
I'm done.
Okay. All right. Before starting the solution, let us understand what exactly we need to calculate. In the problem statement, if you read the problem statement carefully, what is the given data? That the dimension of the section is already given, the width and the overall depth of the section is given, the details of tension reinforcement is also given, that is four number of 20 mm diameter steel is provided on the tension side. So AST we can find out. Then it is also mentioned that the beam is subjected to ultimate moment and we need to calculate the ultimate torsional moment. It means if we calculate the overall moment resistance capacity of the given beam, which will be the addition of both the moments, that is ultimate moment as well as torsional moment. So if we could able to find out the moment of resistance given by the shown by the beam, then we can easily find out what is the ultimate torsional moment resisted by the beam. Okay, so first of all, before solving the problem, we need to understand what exactly we need to calculate and what is the given data. Okay, so we need to find out in short what is the total moment carrying capacity of the section, that is MUR. We need to find out. All right, so let us write down now the given data first. Okay, so the given data is the dimension of the beam is given, effective width is given, the value is
350 mm.
350 mm, then overall depth is given capital D,
800
800 mm, and the effective cover is also given
50 mm.
50 mm. So we can find out the effective depth as 800 minus 50. What is the value?
750.
750 mm. Okay. Then the details of reinforcement is also given. So I will directly calculate now AST. It is clearly mentioned that there are 4 number of bars, right, of 20 mm diameter. So pi d square by 4 into number of bars. Find out the value.
1256.63.
Point.
63.
Okay. 0.63. All right. AST is already given. Then they have also given the bending moment value, which is mu. What is the value?
215 Newton meter.
Your voice is breaking. 215 kilonewton meter, right? And the details of material must be also given. That is required because FCK FY value is also required. So I will directly write down FCK.
M30 FP415
FCK is
30.
30 megapascal and Fy is 415. Okay. So we have to find out now the total moment resisted by the beam. Okay. So we can write down the total moment of resistance. Total moment of resistance, that is MUR, will be equal to, obviously for equilibrium, whatever is the external moment acting on a beam, the entire moment should be resisted by the beam. Okay, so whatever is the MUR, that is a moment carrying capacity of the section, it should be equal to or greater than the external moment acting on a beam. Now the external moment acting on a beam is in the two forms. One is the ultimate bending moment and second is the torsional moment, which we wanted to calculate. Okay, so when bending moment and torsional moment both are acting on a beam, we calculate the equivalent moment, total moment, which is having the effect of both these moments, which is called as ME1. Am I right? So this will be equal to ME1. Okay, MUR will be equal to ME1. What is ME1? What is the expression for ME1?
MU plus MT.
Mu plus MT. So we have this Mu value, we have to find out MT. That is the problem. Okay, now to find out this MT value, we have to also calculate first MUR. That is the moment carrying capacity of a section. And that you can easily find out because it is a singly reinforced beam. The area of the steel in tension side is already given, so it is a singly reinforced beam. And for singly reinforced beam, we have to find out MUR. So what are the steps? And it is a rectangular beam. I mean to say it is not a T-beam. So what are the steps to find out MUR for singly reinforced rectangular beam? Forgot? You must be revising everything now because next week you have examinations. What is the first step?
FSC equals to 0.87 FY.
Your voice is breaking.
FSC equals to 0.87 FY.
FS?
C equal to 0.87 FY. We are assuming.
What is FSC? What is FSC?
And stress resisted by us concrete.
There is no compression steel in the beam. So why we need to calculate FSC? I repeat, we have to calculate the moment of resistance given by or shown by the beam. Now this beam as per the given data is a rectangular beam and it is a singly reinforced beam. That is, the reinforcement is provided only on the tension side. There is no reinforcement provided for the compression side to resist the additional movement. Okay. So what is the first step to find out MUR in case of rectangular singly reinforced beam?
Find WU.
Your voice is not clear. I'm not able to hear anybody clearly.
Find WU.
WU. Why WU?
Find out
ma'am. I'm to find
ma'am,
XP.
find out XU.
X2 find करायचं मॅडम आधी आणि ते 0.87 AST beam आणि 0.42 चं नाव देतात.
And we have to locate depth of neutral axis also. Basically.
Low. Low.
आवाज येत नाहीये.
हा आता येतोय.
येतोय का आवाज आता? हा, माझ्या इथलंच इंटरनेट गेलं होतं थोड्या वेळासाठी. ओके फाईन. हॅलो.
Yes, ma'am.
Yes,
Ritik. You were talking something na. Please, can you please repeat?
तेच बोलत होतो की तुमचा जरा स्लो दिसत आहे.
हाँ, स्क्रीन मी मुद्दाम ऑफ केलाय कारण मला समजत नाही की कोण बोलतंय ते. When I keep the word file open na, I'm not able to really out.
आवाज ब्रेक होतोय मॅम तुमचा.
Just a moment. हॅलो, ऐकू येते का आता?
ma'am.
हो मॅम.
हा, ओके. आता मला फटकन सांगा कसं, व्हॉट इज द फर्स्ट स्टेप?
And we have to find out XU.
Yes, we have to find out XU first, right? That is the depth of neutral axis. And then simply we have to make use of the MUR equation, either CU into ZU or TU into ZU. It is better to use TU into ZU because we already have the details of area of the steel, right?
Yes, ma'am.
So the first step to find out XU, what is the formula of XU?
0.87 FY upon 0.87 FY upon
AST पाहिजे ना?
0.36 FCK.
0.36 FCKB.
FCKB, correct. Okay. So we have all these values. Let us put all the values and find out XU. So it is 0.87 into FY is 415. AST we have already calculated.
X is 0.02.
Directly you have calculated XU?
हा XU. X is
हाँ,
0.02.
थांब ना, 1 मिनिट थांब, मला complete करू दे. 1256.63. 1256.63 divided by 0.36. FCK is 30. B is B का है B की value
350.
350. So what is XU? Just a moment, guys. Okay, what is XU?
X 120.02.
I'm 180.
120.02 is the correct answer.
Ma'am, it is
120.02 is the correct answer. Now, to be on safer side, we need to do one more step here to make sure that whatever the formula of MUR we are using is correct. That is based on the area of the steel. The formula we have to use, that is TU into ZU, or we have to use CU into ZU, and that depends upon whether the given section is under reinforced and over reinforced. So we have to find out first whether the given section is under reinforced or over reinforced. For that, we have to compare the XU with XU max, right? So what is XU max now for this beam?
0.48 into D.
Point
48.
48 into D. Tell me the value.
It is
360.
ma'am.
yes.
Guys, there is some problem with internet today at my place, so I'm not able to hear you clearly. I hope you all are able to hear my voice clearly.
Yes, ma'am.
Okay. So let us compare XU max with XU. Now XU is coming less than XU max. So the section is?
Under reinforced.
Yes, section is under reinforced. Now which formula we can use here?
0.87 FIST.
Yes. So the easy formula.
317.40 kilonewton meter.
अरे थांबा रे किती गडबड करायला लागलास. MUR is equal to 0.87 FYAST into bracket formula सांगा.
D minus 0.42.
D minus 0.42 XU.
सांगा आता MUR.
317.40 kilonewton meter.
317.40
kilonewton meter.
kilonewton meter. This is the MUR, total MUR. Now we have to find out MT. So we know that MUR is equal to ME1, that is equal to MU plus MT. So let us put all these value. MUR is 317.40. MU is given value. What is the value? MU?
120.02.
MU
215 kilometer.
215.
1.52.
Plus MT. So find out now MT.
$112.40.
112?
102.4.
102, ma'am. 102.
102.
102.4. असे सिली मिस्टेक्स करू नका बरं का एक्झाम मध्ये. It is online and MCQ based exam. If you do silly mistakes in calculation, you will lose marks unnecessarily. Steps la marks nahi hai tata ISC la. Final answer whatever you will select, based on that you will get marks only. So please make sure your calculations are correct. You are doing the calculations correctly. And that too you are using calculator, na? Still you are making mistakes. Okay, MT value we have calculated. Now what is exactly we have to calculate? Not only MT. MT is actually the effect of torsional moment on the beam. So truly speaking, we are required to calculate torsional moment, that is TU. Okay. So based on MT, there is a formula, or what is the formula of MT?
MT is equal to TU into 1 plus D upon B divided by 1.7.
Correct. Put all these values now in this equation. We have MT, we have D, B. We can find out TU now easily. What is TU? Guys? Okay.
52.98.
52.98 kilonewton meter. Okay, so this is our final answer. Okay, TU is equal to 52.98 kilonewton meter is the final answer. We have to find out ultimate torsional moment. Is it clear? This is one particular type of a problem which can be asked based on the torsion. Now we'll consider the next problem. Any doubts in this? Students?
No, ma'am.
No, ma'am.
Okay. So the next problem is this one. Let us solve this problem. Now this problem I am not going to solve. I will simply ask you the values. You have to tell me the values. Okay, because this you will solve right now in the class. A rectangular RC beam of size 250 by 500 mm with effective cover of 40 mm is subjected to following action. Factored bending moment 90 kilonewton meter, factored torsional moment 60 kilonewton meter, factored shear force 50 kilonewton. M25 and Fe415 materials are used. So note down this problem in your notebook and start solution. It is the similar problem which we have solved on Monday. Only there is a small change. There I will come in the picture for solution. Have you noted down the problem statement? Guys?
No, ma'am.
झालं ना? Yes. So what is the
No,
first
ma'am.
step?
Continue करो.
Okay. आज मला नाही ऐकू येत आहे नीट काहीच. Shall we start solution?
येस मॅम.
मॅम 2 मिनिटात ते स्क्रीन दाखवू ना परत एकदा, ते ब्लर होत होतं मग. हा फुल स्क्रीन करा ना मॅम ते. येस मॅम झालं.
Okay. So the given data is moment is given, bending moment is given, then torsional moment is also given, and shear force is also given. Size of the beam is also given. AST is not given. Okay, so we have to find out the AST, that is area of steel required to resist both these moments, bending moment as well as torsional moment. And then we also find out, we need to find out the shear carrying capacity of the beam also. So the problem is exactly similar to that of what we have solved during Monday's lecture. Okay, let us start the solution. The first step is, I will write down here problem number 2. This was problem first. So what is the first step?
Calculate equivalent bending moment.
Yes, so find out ME1. So to find out ME1, you have to find out first MT. So quickly tell me what is MT value. I will not write down all expressions now. Find out
112.02.
again 1.
112.02.
Okay. Put the values of MT and MU in the equation and tell me ME1.
202.02.
202.02, right? Now, what is the step? We have to compare MT with MU, right? What is the MU value given? I will write down somewhere here. What is the MU value given?
90 kilonewton.
90 kilonewton meter. Okay. Compare MT with MU. If MT is less than MU, then we have to calculate only the area of the steel required on tension side. If MT is greater than MU, then we need to calculate the area of steel which is required to be provided in compression side also. Okay. Now this is the second type of a problem where MT value is coming greater than MU. So we have to provide the steel on both top and bottom or on both compression and tension side. Okay. So just write down one statement: as MT is greater than MU, steel is also required to be provided on compression side. Okay. Now to find out the area of steel required to be provided on compression side, we have to make use of ME2. Okay, ME2, that is the excessive moment. MT and MU difference between these two. Okay. So for ME2, we have to first calculate ME2. We provide the area of steel for ME2 on compression side and for ME1 on tension side. So what is ME2? ME2 will be MT minus MU. What is the value? Are you there, guys?
92.02.
Can you please tell me again?
22.
22.02.
Okay, 22.02 kilonewton meter. Okay, so for this value of moment, we have to calculate the steel to be provided on compression side. And for this value, ME1, we have to find out the steel on the tension side. Okay, so I will simply write down now the calculation for longitudinal reinforcement. Longitudinal reinforcement. We will first calculate at bottom. Okay, that is for ME1 or at tension side. Okay, so what is the formula of AST? Simply write down here. AST is equal to 0.5 FCK upon Fy into bracket 1 minus under root 1 minus 4.6 ME1 divided by FCK BD square outside the bracket B into D. Okay, put all the values and find out AST. So you do the calculation and tell me the value.
One six three 1637.91. mm square.
1637.91 mm square. Okay. Compare this with AST minimum and AST maximum. Tell me the value of both minimum and maximum value.
AST minimum is 216.7.
Okay. And maximum?
4,600.
Okay. So we have to provide this area only. For this now, let us find out number of bars. So let us assume, let us use 25 mm diameter bars. I'm using the same diameter bars as we did in earlier problem, that is during Monday's problem. We have used a combination of bar diameters, right? 25 plus 12. In the same fashion also you can do here, or you can use the same bar diameter. It's up to you. Design is based on the choice of the designer always. Okay, so let us use 25 mm bar diameter. So I will find out number of bars.
3.3.
3.3. It means 4 bars we have to find out. So what is the provided area? AST provided. Pi d square by 4 into 4.
163.5.
1.5.
963.5.
Okay. See, there is a difference between the required and provided, 1600 and 1900. So you can go for the combination. But here 25 mm 4 bars are required. How will you make the combination? It is very difficult because normally we do not go for 30 mm diameter bars. Hmm? If you go for 30 mm diameter bar, then combination is possible, 30 and 12, 30 and 16, like that. But normally 25, if it is required 25 mm 4 bars, then don't go for the combination because it itself the area requirement is higher, 1637. So let us use the same thing here. So just write down, providing 25 mm 4 bars on tension side. Okay. Now the next we have to calculate the area at the top. Okay, that is at the top or compression side. So this AST is calculated for ME2 value. So again I will write down the formula only, 0.5 FCK upon Fy into bracket 1 minus root 1 minus 4.6 ME2 divided by FCK BD square into BD. Okay, 4.6. So put the values and find out AST. Again, you need to compare this value with minimum and maximum values. Guys, value. What is the value? What is AST you're getting?
135.53.
Yes, 135.53 mm square. Comparing this with AST minimum, now AST minimum will remain same. Na? The value will not change, whatever we have calculated earlier. The value is 216.7. So this is too low. 216.7 mm is the minimum area of steel and the AST required is lesser than minimum. So we have to provide the minimum value only. Okay. So AST should be 216.7 mm square. Okay. So for this now find out number of bars. Now the area required is very small. So we can reduce the bar diameter. So let us use 12 mm diameter bars. Okay, so number of bars, find out number of bars using 12 mm diameter and this area.
1.9.
1.9, so 2 bars. Okay, so just write down, provide two 12 mm diameter bars on compression side. Okay, here our calculation for area of steel finishes, and the next step is design for shear. Now these steps I request all of you to do or complete as a homework, because currently I'm not able to continue with the lecture as there is a pain with my eyes, so I'm not able to see your screen continuously. So today design for shear, that part you complete as a homework. Now our problem will not end with this. After design you have to find out the whether the side face reinforcement is required or not. Obviously the overall depth is greater than 450, so side face reinforcement will definitely required. So that calculation also you need to do, side face reinforcement calculation. So all these you please complete as a homework today. Okay guys?
Yes, ma'am.
Okay. I'm giving you the link for attendance. All of you quickly give me the attendance on this link.